What do Google Maps, Minecraft, 3D printing, and the pixels on your phone have in common? That's right, all of these rely on coordinate systems. The title must have given it away. The coordinate system is a tool we take for granted. We punch equations into powerful tools like Desmos and sketch detailed graphs without a second thought. But graphing wasn't always this straightforward. In fact, for a long time, visual geometry and mathematical equations were kept separate. So, how did we get the coordinate system? And why does it even matter? This is the story of the rise of the coordinate system. For much of ancient history, mathematics was tied in some way to the stars. From the early Mayans to the ancient Egyptians to the Greeks, celestial observation was a central hub of all. Thus, it is only natural to ask, how do you know where a star is? Somehow, you have to pinpoint its exact location and write it down. To achieve this, the Greeks used a coordinate system likely developed by the great ancient mathematician Hipparchus of Nicaea. The Greeks thought of the night sky as a giant sphere. To plot a star on the sphere, one must find the celestial North Pole. Since the Earth spins around like a top, this North Pole is the region in the sky that the stars appear to orbit. In addition to the North Pole, Hipparchus used the ecliptic, the path of 12 constellations known as the zodiac. To pinpoint the location of a star, Hipparchus would first find the angular distance of that star relative to the celestial North Pole. Then, he would find the angular distance of that star to the path of the zodiac constellations. The spot where the two paths intersect represents the location of the star. This is one of the earliest known examples of a coordinate system. You have a reference point, an angular distance, and a point plotted. Several hundred years later, Ptolemy used a similar method to describe locations on Earth, which represent the longitude and latitude. Now, the Greeks isolated the use of coordinate systems to geography and astronomy. When dealing with pure mathematics, they used geometry. When we think of Euclidean geometry, we naturally construct areas using a coordinate system, or something similar to that. But the Greeks didn't think of math this way. Mathematicians like Apollonius of Perga dealt with equations and shapes separately. From their perspective, algebraic relationships and geometry were generally treated as two different subjects. That's because, up to this point, mathematics was structured and envisioned through physical, geometric ideas. Even though we think of areas and the Pythagorean theorem as equations, they didn't. To them, geometry is proven with shapes, not equations. And this divisive mindset between equations and geometry took a long time to change. By long, I mean over 1500 years. In 1591, a mathematician named François Viète decided to introduce something revolutionary to mathematics: the use of letters to represent quantities. Up until this time, many mathematicians wrote out their equations as sentences. For example, to write this equation, a mathematician would have to write 3 times the square of a number plus 5 times the number equals 20. As you might imagine, this demands a lot of time and paper. So Viète used variables, letters, specifically vowels, to represent unknown values. By doing this, Viète laid the groundwork for equations based purely on compact mathematical notation. And mathematicians really liked this idea. This is where René Descartes comes onto the scene. Descartes built off Viète's use of letters for variables, but instead of vowels and consonants, Descartes used A, B, and C for known values and X, Y, and Z for unknowns. If X, Y, and Z are familiar, that's because they are prominent variables that we still use in modern coordinate systems. Descartes is often credited with laying the foundation for the Cartesian coordinate system. In fact, we call it the Cartesian coordinate system in honor of his last name. Legend claims that Descartes was lying in bed one day when he saw a fly on the ceiling and was inspired to determine the exact location of the fly. The sides of the ceiling looked like axes, so Descartes was able to plot the fly like it was on a graph. But there's a problem. This probably didn't happen. Contrary to common belief, Descartes likely preferred algebraic rigor over graphical visuals. He disliked the geometric demands of constantly sketching shapes. So, what if everything could be written in algebraic shorthand instead? Math problems like this could be solved more rigorously and systematically than geometric sketches. With Viète's newly established variable system, and in an age where geometry and equations still had some tension, Descartes sought to translate geometric ideas into algebra. Although he didn't use any XY graphs in his works, he established the connection between geometry and algebra. Descartes' work laid the foundation, and the development of the Cartesian plane progressed slowly. Later, a mathematician named Frans van Schooten popularized Descartes' work by translating it into Latin. He also helped popularize visual coordinate diagrams using positive x and y axes. Over time, mathematicians extended these coordinate methods to include both positive and negative values, producing the familiar four-quadrant Cartesian plane we use today. Today, we use the Cartesian coordinate system to create graphs and charts, powerfully visualizing mathematical ideas. We construct 3D models using an expanded coordinate system with 3 axes. Graphs and coordinate systems are used everywhere, from sound to chemistry, from economics to growth models. What began hundreds of years before Christ took almost 2,000 years to fully develop. From Hipparchus to Descartes, the coordinate system redefined the usefulness and application of mathematics, serving as the bridge between algebra and geometry. There are so many names, some unmentioned in this video, some perhaps still unknown, that played a key role in the development of the coordinate system. In the words of Newton, truly our modern progress is thanks to the giants who came before us. So the next time you use your GPS, play your favorite video game, or watch a Dino 101 video, thank the coordinate system.